In this video, we're going to prove the following lemma. If P and Q are both different primes such that A to the P is congruent to mod Q and A to the Q is congruent to A mod P, then A raised to the P times Q is congruent to A mod PQ. Please note the symmetry here. Like in the the second one, if I replace P's and Q's, I get the first one. Okay, there's symmetry between the P's and the Q's. So for example, if I were to make the comment that A to the P must be even, then A to the Q must be even. They're pretty much the same statement, except when you take them together. But they're pretty much the same statement. Okay, so now we know, or it is known that it's basically a lemma, I guess, of Fermat's Little theorem, that A to the Q raised to the P is congruent to A to the Q mod P. You're more familiar seeing it, well, let's say big A. A to the P is congruent to A mod P. Well, all they're doing is changing capital A. They are calling it A to the Q, which is fine as long as they're integers, and they are. P and Q are prime, which means they're positive integers, and A is positive. Okay, so we know that. Now, we're given the following. We are given that A to the Q is congruent to A mod P. Well, this here is congruent to A to the P, which in turn is congruent to A. Everything in mod P. Well, combining yields the following. Now you have the transitive law. If A is congruent to B mod J and B is congruent to C mod J, then A is congruent to C mod J. There's a video proving this on my channel, of course. So another way of writing this here is A to the PQ, and it is congruent to this, which is congruent to that, which is congruent to A mod P. Okay. Similarly, due to symmetry, I can restate that interchanging A, P, and Q. So I'll still call it A to the PQ, and this is congruent to A mod Q. What did I mean when I said I can call this PQ? I really should be calling it QP, because I'm supposed to interchange the P's and the Q's. But I didn't. Okay, so now we have these two statements, say 1 and 2. So what can we say about statement 1? Well, let's actually put it up here. This says that P divides A to the PQ minus A. That's what that statement means. That a to the pq is congruent to a mod p. This one says that q divides a to the pq minus a. So we have p and q dividing the same thing. Okay, but note that p and q being different primes, that implies that the GCD of p and q is 1. That is, they don't have anything in common. For example, if you have 3 divides, well, let me figure out a good one. Okay, 3 divides 30, goes in 10 times, and 6 also divides 30. This does not imply that product divides 30. Why is that not true? Why doesn't 3 times 6 go into 30? Because these are not relatively prime. 30 is what? 2 times 3 times 5 over 3 times 6. Well, this 3 goes into that 3. But we used up the 3. We have the 2, but we no longer have our 3 to get 6. So this 6 can go into it. But if these two numbers were relatively prime, like maybe 3 and 7, and here we have 63, which is 7 times 9, and I'll write 9 as 3 times 3. Now, when you kill off the 3, it didn't affect the 7s. Okay, this 3 did not have a 7 in it. When you killed off, let's say I kill it off differently. 2 goes in here, 3, well, let's say 3 goes in here 2 times, and 3 goes in here 1 time. And then I go 2 goes into 2. I used up that 3 to kill off the 6. I don't have another 3. But if these two numbers had nothing in common, and they both went into the numerator, then their product will go into the numerator. Okay, I hope that's clear. That's very important to see. Okay, so since P divides this and Q divides this, we have that P times Q divides a to the p cubed minus a. But this implies that this is congruent to that mod pq. A to the pq is congruent to a mod pq. And what's really cool about that is then, that is, this is what I wanted to show. If all this stuff before the then this is true. Yep, that's what I just showed. There it is. Proof is done. It's valid. If you like seeing mathematical proofs like this, definitely consider subscribing to my channel. Leave a comment, click the like button. See you guys in the next video. Watch and learn.